I'm Kathy Manley. This video covers Lesson 5, Virtual Pet Mini Project from Course F. The purpose of this video is to outline computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies to incorporate in the lesson, to model pedagogical strategies for implementing the lesson, and to review computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies addressed in the lesson. There are 3 lessons that we've asked you to do with your students this fall. Those include Lesson 3, Making Sprites, Lesson 5, a mini project with a virtual pet that we're covering today, and Lesson 8, a mini project with user input programs. There are also some additional lessons that you may want to use with your students, so we encourage you to explore the course. Computational thinking concepts are the concepts programmers engage with as they program. In this lesson, students will focus on sequence and events as shown in bold. Powerful ideas are skills within a domain that change how we think or perceive the world and problem solve. The powerful ideas that operationalize computational thinking are also the computational practices that programmers develop when they engage with the computational concepts. In this lesson, we will focus on decomposition, algorithm, and debugging as shown in bold. Students will also use additional critical thinking skills such as compare and contrast, cause and effect, predict, problem solving, plan, and observe. In this video, I will demonstrate this lesson and point out opportunities to use the following pedagogical strategies to support student learning. We will use student-centered learning where students have time to play, think, and code, as well as direct instruction on key elements. We will also use the PRIM approach where students predict, run, investigate, modify, and make a program. Lastly, we will focus on the process of problem solving. Lesson 5 uses behaviors and events to bring sprites to life. Because students have not yet used events, unless you choose to do Lesson 4 with them, you may want to show them the first video in Lesson 4, which is Puzzle 2, Sprites in Action. This video will introduce your students to events, an essential component of interactive media that allows the user to interact with the program. If you feel your students need practice creating events before beginning this lesson, you can have them work through some of the puzzles in Lesson 4. In Lesson 5, we're going to begin with this exploration of a virtual pet. So the first thing we want students to do is just to observe the program. What do they think the sprite begins blocks are doing? These are behaviors that begin an effect when we click run a cause. What will the when touches blocks do? These are events that begin an effect when we interact with the sprites. Run the program and then maybe examine things with them like why can't they move the dog? Take a look at the program. Why can they move the dish and the ball but not the dog? When I move the ball to the dog and then move it away, why does the dog not stop spinning? What does the program show that I have to do to make the dog stop spinning? Where do we see this? Where does the order or sequencing matter in the program? Where does the sequencing not matter? What can you change in this program? What problem do you want to solve and how can you solve that problem? And then just encourage them to play with the program, make changes, see what happens if they change different variables. When they're ready to move on, and you can spend as much time as they need in this part just to get them comfortable. When they're ready to move on, they'll work through puzzles 2 through 6 to create a program similar to the one that you see here in Puzzle 1. So the first thing that they're going to do here in Puzzle 2 is they're going to make 2 sprites, a pet and its food, and put them in different locations, change their sizes. So I'm going to start right now just with this one in creating a monkey and a banana. So I'm going to go to Sprites, take this Make New, and I'm going to change my first costume to a monkey. And I think I'm going to move him using this location piece. I'm going to move him over to the left so I have room for my banana. And then I'm also going to make a new sprite. And this time I'm going to make a banana. And I'm going to move it over a little bit to the right. And again, they'll want to kind of predict what they think is going to happen here, and they can click run. But I'm looking at this and thinking that banana looks awfully large. I think I want to change the sizes here. So I'm going to go back to sprites and I'm going to set the size And I think I want to make my monkey bigger. So I'm going to change that one to 150. And if we talk about cause and effect, in this particular case, all I had to do was change this number, the cause, and the effect was that the monkey changed the size. And I'm going to do the same thing again. And I'm going to do this with the banana. I want to change the banana and let's make it smaller. Notice when I changed the banana, because this was already set to 50, the banana already becomes smaller. I don't need to change the size unless I decide that that's too small. When they're happy with what they've done here to create these two sprites, they can click run. And if we think of having them predict what the cause and effect here is going to be, there's nothing extra that's going to happen when I click run. Notice that we've already made all the changes that we were going to make. In puzzle 3, they're going to make an object so it can be draggable. So if you remember from the first puzzle there, they were able to drag objects. We want, in this case, for them to be able to drag the banana. So I'm going to click on behaviors, and I'm going to use this sprite begins. And when I do this, I need to decide which sprite I want to use. Well, I want to be able to drag the banana. So I'm going to change this to the banana. And then the behavior that I want is to be draggable. Now, this time when we click run, what we should notice is this cause and effect is different. I'm going to notice that the banana is now able to be moved, but I'm only going to notice that if I actually start moving it. So we're going to click run, and it's my input that's going to cause this banana to have the effect of moving.
Da-da-da!
In puzzle 4, event blocks are going to be introduced here, and they're independent of the program sequence. So they don't need to touch the current blocks. So we want to make some problem solving approaches here. It says we're going to use a new when touching block to make your pet grow when it eats. So the problem is, how do I make the monkey grow when I feed it a banana? And so the solution is that I'm going to need to make the monkey change its size whenever the banana touches it. And I'm going to make a program to do this. So I'm going to click on events, and I want this when touches. And I need to change this to a monkey and a banana. So when the monkey touches the banana, or it could be the banana touches the monkey, that order doesn't matter. So we can talk about sequencing a little bit there. And then I want to take my sprite here and I want to change the size. So I'm going to change the size of my monkey when it touches the banana. And I'm going to go ahead and just leave it at 10. So again, have the students make a prediction. When they click run, what do they think is going to happen? So when I click run and I drag the banana to the monkey, each time it touches the monkey grows. Puzzles 5 and 6 have students add another sprite, add behaviors and events. When students are done with those, talk to the students about their choices in these puzzles. Review problem solving, cause and effect, and debugging when something wasn't working the way they expected. Encourage them to try some new things. Have students compare and contrast the events and the behaviors or the different types of event blocks. And when they're done with all of that, they can go to puzzle 7, which is free play. Before students begin, ask them to share what blocks they see in the menu that they haven't used yet. Have them share predictions about what they think those blocks might do, and encourage them to use those new blocks. Once they're done with that, we want to wrap up, ask students what they learned. Remember, play is part of learning, so encourage them to share fun aspects as well as the computational thinking concepts and powerful ideas that they remember. Review problem solving to encourage them not just to jump in and drag the blocks. Talk about the role of observation, prediction, cause and effect. Review the compare and contrast of behaviors and events. Ask them what they did when something didn't work the way they expected, and share with them that fixing a program that isn't working is called debugging. Ask them if they saw more than one way to accomplish each puzzle's goal, and then talk to them about sequencing. Did the order matter particularly that they needed to create a sprite before they could give it a behavior. But when they create events, the order in which events happen depend on the user. One of the other things that's really nice in this particular lesson is it comes with a cross-curricular activity. So if you pull up the lesson plan and scroll all the way to the bottom, you'll see this providing energy for your pet activity. And when you click on the lesson, there are tons of resources here for you. In this lesson, what the students do is they create a scientific model showing a decomposer, producer, and consumer. And the lesson provides links to readings, worksheets, videos, and note-taking tutorials. You can either complete this activity after this lesson, or you can wait until after lesson 8, where students will learn to add text so that the sprites will speak. I think that the students will enjoy creating these virtual pets. Let's take a moment to debrief. We covered several computational thinking concepts and powerful ideas that align with this lesson. Students needed to create a sprite before they could assign a behavior or event to that sprite, so they learned about sequencing. Students created events to allow the user to interact with the program. When talking with students about the goal of a program and how to build the blocks to accomplish that goal, you're helping them to decompose that code by breaking that larger project into smaller pieces. Algorithms are the steps students use to complete a task. And when the program didn't run as expected, students worked to debug their programs. We applied critical thinking skills by having students compare and contrast the events and behaviors they used in the puzzles, having them observe the cause and effect using draggable sprites, make predictions, solve problems, make a plan, and observe code. We also employed a variety of pedagogical strategies by encouraging students to play, think, and code while providing direct instruction for key elements. Students also focused on understanding the problems, devising solutions, and using the PRIM approach to investigate and make their programs. When you're working with students, it can be helpful to reinforce this vocabulary, especially in other classroom activities, to reinforce the skills that they're learning here. We encourage you to address additional computational thinking concepts and powerful ideas whenever the opportunity arises. Thank you for watching this video.